प्यारे बच्चों, today we are going to start problems based on differential amplifier. So first of all, we will take one example here for common mode operation. This is the given figure. You can name this figure. So in this diagram, we have a common mode input VCM, which is common to both gates of Q1 and Q2. ID1 is the current through Q1, ID2 is the current through the Q2, and VD1 and VD2 are potentials at the drain terminals. We have two supplies, source supply and drain supply, and these are given parameters. Supply voltages are given. VDD equals PSS equals 1.5 volts. Transistor constant parameter is given, and VT threshold voltage. This current source is given 0.4 volt. RD is given. So first of all, in part A, we have to find out overdrive voltage and gate to source voltage for each transistor. So now we are going to start solution of this problem. How can we solve? So first write the basic expression to calculate the overdrive voltage. These are given parameters. So in first part, we have to calculate overdrive voltage. To find out the overdrive voltage, you can see that because this is common mode signal, so this current I is equally divided into two parts. This I breaks into two parts, I by 2 and I by 2, because both transistors are similar. So current through any transistor is given by, in saturation mode, this is the relation. So from this relation you can find out overdrive voltage. So you can write I upon Kn dash W upon F in under root. So you can put all values and just I am writing answer directly. You will get 0.316 volts. You can check. Put all these values, then you will get the overdrive voltage. And in second thing is the VGS, gate to source voltage, is from gate to source. Gate is common and source is common, so voltage is same for both transistor. Gate to source voltage is in terms of overdrive voltage. This is the overdrive plus threshold. This is the gate to source, or you can also say overdrive is the difference of this VGS minus VT. This is the threshold voltage, minimum required voltage to operate transistor in saturation, and overdrive is the value to the threshold. So this is the GS. So we know overdrive voltage is 0.316. VT is given. So after putting these two values, you will get VGS is simply 0.82 volts. So this is the first part. In second part, you have to calculate for VCM equals 0, find source voltage, two drain currents ID1, ID2, and two drain voltages D1 and D2. So these are voltages. Now you have to calculate all these things for VCM 0 means this is 0, no voltage is there, and this is grounded for first part. So obviously VG gate voltage is 0 for this case because this is grounded. Okay, and you know that VGS is 0.82 volt. Then we can calculate source voltage because VGS equals VG minus VS. Okay, that is 0.82 equals 0 minus VS. So VS equals minus 0.82. So this is the first part. VS. When common mode signal is 0, then common source. This is the common source. So voltage of this terminal is VS. So we can find out this because we know VGS. Okay. So this way. Now you can calculate easily these two currents, ID1 and ID2. Okay. So ID1, ID2. This current I is given how much? Current I is given 0.4 milliamperes. So this is equally divided into two parts. So ID1 and ID2 are equals given by 0.2 milliamperes. So these are two currents in two drains. So now we can calculate next part VD1 and VD2. Okay. So in this part both are same. VD1 is both are same. And what are values? VDD minus you can say ID1 into RD or VDD minus ID2 into RD, both things. So from here you can calculate this is the value comes out to be 1.0 volt. So this is all about the second part. Now calculate all these values for VCM given something else. So this is the VCM. In C part, calculate all our values for repeat part B for VCM equals plus 1 volt, and in next part repeat part B for VCM minus 0 point. Okay, so these are two different cases. In one case common mode signal is positive and in another case common mode signal is negative. So what is the approach? This is same. One thing is similar here because signal applied is common to both gates. At both gates we have same input. So current will divide equally into two parts because both gate terminals are same. So terminals are same, but we have different value of Vs. Okay. So VGS is 0.82 volts. That is Vg minus Vs is 0.8. Now Vg is different. In this case, okay, in part C, because this is plus 1 volt, so you can write this is plus 1 minus Vs equals 0.82 volt. So Vs equals 0.82 minus 1, that is minus 0.18 volt. Okay. So in this part, Vg minus Vs, Vg, I think it is Vg minus Vs equals, no, that is wrong. Since so Vs equals plus 1 minus 0.82, that is 0.18. Okay, and all other things are same because current divides equally. ID1, ID2 same in two parts. So this is same as in previous part, that is 0.2 milliampere, and BD1, BD2 both are equal. This is same as in previous part. So BD1, BD2, this is also 1 volt. So only thing differs is this part, PF. So source voltage is different. All other things are same. As far as this signal is common mode, these two currents are same, and this is half of this current. Okay, and these two terminal voltages are same, VD1 and VD2. Only differs this source voltage, and for operating condition VGS is same. So if we change this voltage, common mode signal, potential at the source terminal varies. Similarly, in next part, we can calculate all other things are same. In next part, we have only one thing different, that is Vs. And in this part, Vs comes out to be minus 1.02. All other parts things are same. So this is the part of this problem. Few more parts are there in this problem. And one thing is highest and lowest values or common mode signal, maximum and minimum. Next part, what is the highest value of PCM? What is the highest value of BCM, that is common mode signal, for which Q1 and Q2 remain in saturation. Q1 and Q2 remain in saturation. Okay. Highest value of BCM, that is BCM maximum. Okay. So maximum value of BCM. How can we decide? So we have solved this condition. Maximum value formula comes out to be Vt plus Vdd minus half Rd. Okay. So this is the maximum value of this is. Okay. So you can calculate from this maximum, put all values, you will get 1.5 volt. Okay. And minimum value in next part, what is VCM minimum value? So VCM minimum can find out this minimum value by this expression. This is minus VSS plus VCS plus VT plus overdrive. Put all values, you will get minus 0.28 volt. So this is minimum value is decided by this condition, where in this problem minimum, to calculate minimum value, one thing is given, that is VCS is given. Suppose VCS to operate is 0.4 volt. This value, this is given 0.4 volt. So how we can calculate minimum value? Minimum value of common mode signal is decided by voltage drop required to operate this current source. So minimum voltage drop which is required to operate this current source is VCS, means drop across current source, and this is 0.4 volt given, and then we can calculate minimum value. And so this is the common mode operation, and you can note one problem for assignment. For the MOS differential pair, next problem. For the MOS differential pair, find, so problem is same for same figure. Find the value of VID, first part. Find the value of VID, means now we are applying a differential input. Here we are applying a differential input VID that causes Q1 to conduct the entire current I and the corresponding values of VD1 and VD2. So this is the first part. In second part, the value of VID that causes Q2 to conduct. So opposite of this, in second part, we have to find VID to conduct only Q2, means opposite of this part. Here whole of the current flows through Q1 in first part, in second part whole current flows through Q2, and in last part range of the differential output voltage. What is the range of differential output voltage? So what is the procedure? I am giving you answer here. Answer of first part plus 0.45 volt 0.5 volt and 1.5 volt. In B part just opposite, minus 0.4 volt, 45 volt, 1.5 volt and 0.5 volt. And in C part, plus 1, 2, minus 1. How can we calculate this VID? Limits. Okay. Under root 2 BOV. So this is the range. Under root 2 BOV to minus root 2 BOV. This is the range. When whole of the current will flow through this, okay, no current flows through this, and drop here will appear at the VD2. That's why this is 1.5 volt in one case, because this supply is 1.5. So only current flows through this Q1. For the first case, you have, this is the drop, VD1 is 0.5 volt, okay, and so VD1, VD2 in corresponding values of VD1, VD2. These are values VD1, VD2, and this is the value of VID. Okay. So in one part we have value 0.5 volt, in another part 1.5 volt. So you can do this problem for differential input. When differential input is applied, what will happen? As we increase this VID in positive direction, current increases through this, and for one value, whole of this current will flow through this, okay, and current in this Q2 is 0, and just in opposite direction, when this is applied voltage is negative, current will flow through Q2, and current through Q1 is negative. So these are two parts, for positive value, for negative value. For 0.45 minus 4 minus 0.4, and these are ranges. 0.5, 1.5, 1.5. So obviously in first part BD1 is 0.5 and BD2 is 1.5, and in second part this is opposite. In first BD1 is 1.5 and BD2 is. So this is all for today. Thank you.